So today's lesson 5.5, we're going to be looking at ratios. And the big idea, the quotient of two measures with the same type of units is a ratio, which is, again, our first definition here. So it's the quotient of two quantities with the same units. So we've been talking about rates in lesson 5.4, and that was the quotient, so a fraction, division of two quantities with different units, miles per hour, inches per hour, anything like that, two different units. That's a rate, but a ratio is comparing two quantities as a quotient. So as a fraction, we can divide it to get a single number, but it's comparing two things with the same units. So that's what we're going to be focused on here today. And two very common ratios that we're going to deal with are the percent of tax, or the tax rate, or the percent of discount, also known as the discount rate. So the percent of tax, if you want to know what's the percent that something is being taxed, it's the ratio. So it's going to be a comparison as a fraction, a quotient, of the tax to the amount being taxed. So how many dollars are you paying for the tax compared to how many dollars is the item? If you set those up as a quotient and you divide them, you'll find the percent, or the tax rate. Same thing for the discount. That's the ratio of the discount, how much money is coming off the price compared to the original price. If you compare those two numbers as a quotient, as a ratio, and you divide, you're going to find the percent of discount, or the discount rate. All right, so example number 1. It takes Max 15 minutes to ride his bike to school, and it takes Riley 21 minutes to walk to school. So we're going to compare the two. Now they're both in minutes. They're both talking about the same thing, how long it takes them to get to school. So we can set up a ratio because we're comparing two things with the same units. So write a ratio comparing Max's time to Riley's time. Now it's important when you set these up that you do it in the order that it says it. So we're comparing Max's time to Riley's time. So we're comparing Max, which is 15 minutes. And when we compare them, we're setting these up as a quotient, which we use fractions to represent. So 15 minutes for Max compared to Riley's time of 21 minutes. And that's a ratio. You're comparing the two. Now ratios should be fully simplified. So we've talked about that units can cancel each other out if you've got one in the top and the bottom. So minutes are going to cancel out. So we're left with 15 over 21. And since these are fractions, we want to simplify them as much as possible. So 15 and 21. Those can both be divided by 3, and you don't have to show what you divided by, but for the sake of the notes, I'm going to show that I divided by 3 so we can see what happened here. And so our final comparison here is 5 over 7. So our ratio is 5 to 7. Conversely, write a ratio comparing Riley's time to Max's time. So it's just going to be in the opposite order. So Riley's time of 21 minutes compared to Max's time of 15 minutes. Just like the previous question, minutes are going to cancel. We're going to divide by 3. And now the 7's on the top and the 5's on the bottom. So the ratio comparing Riley to Max is 7 to 5. Conversely, the ratio for Max to Riley is 5 to 7. So those would be kind of opposite there, the inverse. All right, so example number 2 now. TV normally sells for $400. It's on sale for $340. What's the percent of discount? If we go back and we look at our percent of discount, that's the ratio of the discount itself, the amount of money coming off the price, compared to the original price. So if I just grab these two numbers and try and set up a ratio, I'm already doing something wrong because we want to know the percent of the discount. So these two numbers represents the original price and then the new price. And so if I set those two up in a ratio, I can find a percent, but I'm finding the percent that the new price is compared to the old price or vice versa. But that doesn't give me the percent of the discount. So I have to compare the discount to the original price if I want to find the percent of discount. Okay, if I set up my numbers another way, I can still find a percent that may be helpful in certain situations, but it's not going to be the percent of the discount. So when I go to put in numbers in here, I'm not going to necessarily grab both of these. The discount is how much money came off the price. So if it was $400 and now it's $340, that means that discount was $60. $60 came off the price. That's the discount. And the original price, it normally sells for $400. Okay, so now if I want to find the percent, I'm going to divide. When I divide these two, I get 0.15. That's the decimal version. And we know that that represents 15%. So it's a 15% discount. Now, if you would set these up in a ratio and you divide it and you put the 340 on top, you would have got 85%. So this number is 85% of this. And so if you said there was an 85% discount, that wouldn't make sense. 85% discount is a huge discount. And obviously just going from 400 to 340, that's not 85% of a discount. But what we can think about is, since this is 85% of this, 85% of the original price, that means they took 15% off of this. So it's another way to think about it. So if you originally divided these and you got 85%, you might say, well, I know that's not right. Oh, okay, 85% is representing how much this price is compared to the original, which means take 85 from 100, you have 15% coming off. Tax is very similar here. So it says the tax on the TV is $23.80. The total cost with the tax is $363.80. What's the percent of tax? So when they figure tax, the amount of tax is based on the original price, right? Not the price after tax. That doesn't make sense. So the percent of tax is coming off the original price. This is not the original price, and that's why we need to be careful. So what am I going to compare? The tax is going to be a percent or a piece of the selling price or original price, whatever you want to call it. So we are given the tax. It's $23.80. We're going to compare that to the original price. And if I divide those two, I'll find out what percent it was of the original price. So I can't grab the 363.80. That's not what I should be comparing this to, because this already has the tax added into it. So what I need to do is take 2380 off of this, since this was the tax added into it, and I'll get back to what the original price was. And if you go ahead and you take 2380 away from this, you're left with $340. So the original price was $340. The tax obviously was added on, and we had this price. So we want to know, what was the percent of tax? What percent of tax were they adding on to this? So when I divide these two numbers, I'm going to get 0.07. We know to move that 2 spots. That's not 70%. That is 7% tax. All right, so quick and easy. We just need to make sure we're using the right numbers when we start comparing the discount and the tax. We're always comparing it to the original selling price, not the final price after tax or after the discount. Okay, if we flip this over and go over to example number 3, now we're going to be looking at some ratios, and we're going to set up some equations to find out the exact amount of something that we need. So example number 3, Bethany mixed 1 part of red paint with 3 parts of white paint. So for every 1 piece, no matter how much that is, 5 gallons or 10 gallons, however much red paint, the white paint needs to be 3 times the amount. So this isn't necessarily 1 gallon of something or 1 pint of something. Just however much the red paint is, the white has to be 3 times that amount. So it's a 1-to-3 ratio. How much of each color will she need to make 5 gallons of paint? So basically, here's what's happening. She's mixing red and white. Okay, not an equal amount of each. 3 times as much white to the red, and that creates the pink that she wants for her wall. And so if she wants to make 5 gallons of paint total, so not 5 gallons of this, not 5 gallons of this, 5 gallons of pink paint. This is the pink paint. So the total red and white together has to equal 5 gallons, but they need to be split up in this ratio so that we end up with pink. So we know it's 1 part or 1 P for the red. And if we add that to the 3 parts, and I'm going to use P, and you can use any variable that you want, but P makes sense for parts here. And this represents the white paint. If I added this all together, this has to come out to, for this specific problem, 5, and that's the gallons. So 1 part red plus 3 parts white has to come out to 5 gallons. Well, very simple equation we can all solve. So we're going to put this together. That's a 4p equals 5. So I'm going to divide by 4 to isolate my variable. And the answer is 5/4. If you divide that, it's a nice decimal, 1.25. So P represents 1.25, but that doesn't answer the question. It says how much of each color will she need? So we need to know how much red and how much white. And before we go and actually find those answers, when we get an answer for red and white and we add them together, we need to make sure we are getting 5. Otherwise, it's not correct. So the red plus the white has to equal 5. So we know red was represented by what? Well, red was 1p, so 1 times p. So just 1 times 1.25. You're just going to get 1.25. So we need 1.25 gallons of red paint. And the white paint is represented by 3 times whatever p is. So we have to do 3 times 1.25. So I'm actually going to write that out. 3 times 1.25. What does that come out to? That comes out to 3.75 gallons, and this is gallons. And if I add those two numbers together, 1.25 gallons of red plus 3.75 gallons of white, you add those together, and you do get 5 total gallons. So it's kind of like a little check, and you know you got it right. Okay, same idea for number 4. I challenge you to pause the video and take the extra couple minutes. Try this problem on your own first before you watch me go through it and see if you can get it right. All right, so let's run through this. A recipe for punch calls for 1 part Sprite, 2 parts fruit punch, and 2 parts pineapple juice. Now, that doesn't tell me an exact amount for each one because it depends on how much punch you're making. If you're making just punch for yourself, 1 glass of punch, and that's different than if you're making for a huge party, but this has to be the ratio. So however much Sprites you got to have twice as much fruit punch and twice as much pineapple juice, which means since these are both 2 parts, these are going to be the same amount. Okay, and they're both going to be twice the amount of the Sprite. So it says you need 20 gallons of punch, so that's the total mix for a family reunion. How much of each ingredient do you need? So we know if we take the Sprite and we add the fruit punch and we add the pineapple juice, it's going to equal 20 gallons. I think it helps if you write this out first before you start jumping in, but at a certain point you can get past that. So the Sprite we're going to represent by 1 part. And we know that you don't have to write that 1 there, so if you just put P, that would be perfectly fine. We know the fruit punch needs to be twice this amount. So 2P. And we know the pineapple juice has to also be twice that amount, and it's going to equal 20. Quick solve that equation. So 1, 2, and 2 makes 5P equal to 20. We're dividing by 5. So P equals 4. And so now let's go ahead and solve for each one of these individually. So we know the Sprite just equals a 1P. So that means 4 gallons of Sprite. And the fruit punch, I'm going to abbreviate here, fruit punch, that's going to equal 2 times P, so twice the amount. So 2 times 4, 8, so twice the amount of Sprite. 8 gallons. And then the pineapple juice, also represented by 2P. 2 times 4, another 8 gallons. And double check yourself. If you add 8, 8, and 4, you get a total of 20 gallons, which is what we wanted. So we know if we want to make 20 gallons of punch in this ratio, we need 4 gallons of Sprite, 8 gallons of fruit punch, 8 gallons of pineapple juice. Mix it all together, and you've got your perfect equal ratio for 20 gallons.